To discuss about the when two vectors are multiplied, if the resultant is also vector, then what will happen and how we can calculate the resultant, that with direction. Okay, so that is what we call it as, what, vector product or cross product. If two vectors, product of two vectors is going to be a vector, then we call it as what, vector product or cross product. Okay, so let us start that one. Vector product or cross product okay, vector product or cross product. Okay, so how we can, in general we can define it as, if product of two vector quantities, if product of two vector quantities is a vector quantity, if product of two vector quantities is also a vector quantity, then product is called, then it is called what? Vector product. Okay, so vector product or what we can call it as cross product. Vector product or cross product. Okay, so this is what the simple general definition. If you want definition in terms of formulae, that we will see later. Okay, so usually this happens in case of what, when the resultant is also having some other direction. If we change the direction of your vectors, what will happen? Direction of resultant will also change. Okay, so for example, the best example is what, again, your screw. Okay, so suppose you are having some screw over here. Okay, so suppose you are having a screw over here. Okay, so if you rotate from in this direction, okay, means before vector was here, this was vector A, and now you are coming to here, this is vector B. Okay, so you are rotating from here to here. When you rotate from here to here, okay, so what will happen? Where this screw will move? Will it move along A or along B? It will not move either along A or B. So where it will move? When you rotate it in this direction, what will happen? It will move in upward direction. Okay, so if you rotate from A to B, so what will happen? Your screw will move in upward direction. Okay, so this is resultant of these two. This is also a vector because it has direction. Why we can call it as vector? Because if we change from this direction, this resultant will change. For example, suppose this is also a screw. Okay, so you are having a screw over here. Instead of moving from A to B, if before you are here at B, now you are moving to A. Okay, if you are moving in this direction, before you are moving in this direction, now you are moving from B to A, from here to here. If you start moving from B to A, so what will happen? It starts going down. Getting the point? If you rotate, it will start coming up. So if you rotate in this direction, it starts going down. Okay, so this is what it is. It will start going down. So where it will move, it will go down. Okay, so this will go down, and this is what going to be resultant. Okay, so direction of resultant is changing. Because of what? Because of changing the direction of A and B. When you rotate from A to B, resultant was in upward direction. When you rotate from B to A, resultant is downward direction. That means resultant is having some direction. Okay, so that is why that is why the product of two vector is also vector, because it has both magnitude and direction. Then we call it as what we call it as the vector product or the cross product. Okay. So in general, how we can write, what is the formula for this one? Okay. So if I consider two vectors, say vector A is along this direction, this is vector A, and this is vector B. Okay, so this is angle theta. Try to understand this diagram. It is like this rotating from A to B, rotating from A to B. It is not exactly on the board. It is going to be there on some plane. So if I take it as some plane, so you can think that it is there on some plane. Okay, it is like this. Okay, so the three-dimensional diagram you have to imagine. So if suppose what from where to where you are rotating, from here to here you are rotating. Okay, so from A is like this and B is coming to here. Okay, so this is what your resultant. This is what three-dimensional. Okay, so same thing I am doing here. I am taking two vectors A and B like this. Okay, so these are what going to be A and B, two vectors. Okay, I am holding like this, but this is in this plane. Okay, this is one plane, XY plane. Say suppose XY plane. Okay, so where will be resultant? Resultant will be either upward or downward. So I will take this as example. So this is what I am going to draw. This is what angle theta. This is what resultant. This is only what I am drawing here. Okay, so diagram will be like this. If you are good at drawing, you can draw it properly. Okay, so this is what the diagram. If I draw it properly, it is difficult to show the three dimensional, but let me try. So A I will take over here, and let me take B over here. Okay, so this is angle theta, and let me take B over here. They are on the like this. Okay, so now where will be resultant? Resultant is going to be here. This is what is going to be your resultant. Okay, so now what you have to do is what you want? We want vector A cross, sorry, not cross B equals to A cross B equals to. So A you write as it is, but you have to take what? You have to take magnitude of A. Then what about B? B you should not take along this one, because you want resultant perpendicular to these two, means you have to take this component along this axis. Okay, so getting the point. Again, you don't get confused. Okay, so it will be somewhere here. Okay, means three dimensions. You can understand. This is X and say this is Z, or this is some Y, and this is Z like this. So it is moving from X towards Y. Okay, so what is its B components along this one? If you take here, it will become V cos theta. Here it will become what? V sin theta. Okay, here it will become V cos theta. This is not required for us. What required is V sin theta. So because of these two, you will get this resultant. So magnitude of V sin theta. Okay, so A cross B is equals to magnitude of A, magnitude of B, sin theta. But this is what? This is just a magnitude. This is just a magnitude. Okay, and now here also it is just a magnitude. If you want to make it vector, what you have to do? Suppose you are having A. If you want to make it magnitude, what you will do? You will multiply by unit vector. Then it will become what? Then it will become vector. So similarly, now here also it is now magnitude. So you want to convert into a vector. So what you have to do? You have to multiply by what? Multiply by unit vector. But which unit vector? I, J, K. Here I have written Z, Y, so X. Resultant is along what? Resultant is along Z. Z means what? You have to take K cap. But I have written, but in general we don't know. In general, we don't know whether it is along X or Y or Z. So that is why what I will do, I will take in general it as a N cap. I will take it as N cap. Okay, so this I have to write N cap. Remember, you should not forget to write N cap. If you do not write N cap, so it is going to be wrong. Okay, in dot product, A B cos theta over, because it was scalar, no need to mention or convert into vector. But here you must and should multiply with n cap, because you are giving the resultant as a vector, not a scalar. Okay, so what is this one? This is nothing but magnitude of vector A. And what is this? This is nothing but magnitude of vector B. Then what about theta? Theta is angle between vector A and vector B. What about n cap? N cap is unit vector along resultant. Unit vector along resultant. Okay, so remember, very very important, if they give magnitudes and whatever your what theta angle, then you can easily calculate. Okay, so suppose if I take some example, if A and B are two vectors in xy plane, if A and B are two vectors in xy plane, then such that magnitude of A equals to 2 and magnitude of B equals to 3, and angle between them theta is equals to say some 30 degree. So find the result. Find result. Okay, so they are in xy plane. A and B are in xy plane. So I will take xy plane over here. So I will take xy plane over here. Okay, so this is x, this is y, this is xy plane. So A and B are there. What? A and B are in xy plane. Okay, so I will take this as A and this as B. This is B, this is A. Angle between them is 30 degree. Okay, if A and B are here, if it is moving from A to B, if A and B are here, so where will be the resultant? Resultant will be perpendicular to this one. Resultant will be perpendicular to these two. Okay, so it is along what? It is along Z cap. It is along Z axis. So your n cap is what? N cap is nothing but your k cap. N cap is nothing but your k cap. Okay, so what you can write here is vector A cross vector B equals to magnitude of A, magnitude of B, sin theta n cap. Okay, so what is A cap? 2. Magnitude of A is 2, magnitude of B is 3, sine of 30 degree, write n cap as it is. So what is this one? 6 sine 30 n cap. So 6, what is sine 30? Sine 30 is nothing but 1 by 2 n cap. 2 ones are 2 3s are. So what we can write? 3 n cap. Okay, so this is what A cross B. So in general you can call it as n cap, but actually it is what? 3 k cap. Okay, so A cross B equals to 3 k cap. Don't worry about how this k cap is coming. Don't worry about that. And as of now you remember, simply you have to mention a unit vector. In general it is an n cap. So about the direction we will discuss properly. Okay, because direction is very very important here, whether it is going for along the x or y or z. So what we got, if suppose you have two vectors, vector A along here and vector B along here, say in the xy plane or something, making an angle theta. So your resultant will be either in upward direction or in downward direction. That depends on whether you are moving from A to B or B to A. Okay. So what we got was we got it as vector A cross B equals to, so magnitude of A, magnitude of B, sine of theta. This is what magnitude. Okay, so if you want to vector A cross vector B, so what you can write? You have to write magnitude of A, magnitude of B, sine theta So end cap is very important. Okay. So unless mentioning end cap, this will not become a vector. Okay. But our result is what? Result is a vector. Okay. So you can just write a formula for end cap also. For end cap, what you can write? End cap equals to A cross B, vector A cross vector B divided by, this will come magnitude of vector A, magnitude of vector B sine theta. Okay, so you can find n cap like this also, or n cap equals to A cross B divided by, what is this magnitude of A, magnitude of B sine theta? Magnitude of A, magnitude of B sine theta is nothing but magnitude of A cross B. So magnitude of A cross B. So this also will give you what? Will give you the n cap. Okay, so very important. But this is what mathematically we can do, but sometimes we may struggle here. But in generally, how we can find, how we can get the, how we can come to know the direction of the result, whether it is moving upward or downward. Okay, so if suppose you are having, say, some xy plane over here. Suppose you have the xy plane. So this is what your xy plane. Okay. So you have two vectors on this xy plane. So from one vector A is here, and another vector B is going to be here. Okay. And it is moving from A to B. Means I want A cross B. I want A cross B. This is what the theta. It is moving from A to B. It is plane. It is plane like this. Okay. On this plane, so it is A and B are there. So where will the resultant? Resultant will be along this direction. This is what going to be your resultant. This is what your A cross B. When you are moving from here to here, when the screw is moving this direction, so what will happen? Obviously, it will move in upward direction. When you reverse it, it started going down. Okay. So same thing. If I take the another xy plane. So if I take the another xy plane, so this is going to be A and this is going to be B. But now what I will do, I will come from B to A. I will come from B to A. I am coming from B to A. So now resultant is what? If you move in opposite direction, so what will happen? It start going down. So this is what going to be your resultant. This is what going to be your resultant. That is what? B cross A. B cross A. That means it depends on direction. If you are going in this direction, it is going upward. If it is coming in along this direction, so it is coming down. So here it is along the positive z axis. So here it is along the negative z axis. So resultant will be going to be what? It is going to be negative over here. So how we can find this resultant? Is there any rule for that one? A very simple rule we can apply over here. Here you are moving from A to B. So you can take your fingers only as a vector A. So you are moving from what? You are moving from A to B. So you can just rotate it. Okay. If you rotate it, so this will become what? This will become from A to B. So your fingers are showing what? Your fingers are showing the moment A to B. So your thumb will show you what? Your thumb will show you what? Direction of resultant. So from A to B, resultant is along here. If it is B to A, so your fingers should come from here to here. So B to A. So what will happen? It will go down. Okay. So you can, with the help of your fingers, you can give the idea of, or you can give the idea of what your direction of resultant. But you should not, one time you will use this one time you will use left hand. It is not possible. You have to use only your right hand. So that rule to find the direction. So to find direction of result. So to find direction of resultant, better to use something called right hand screw rule. Okay, right hand screw rule. Okay, so right hand screw rule means what? If your fingers show the direction of rotation of finger, your thumb will show you what? Direction of movement of the that screw, means resultant. Okay, so suppose Suppose vectors are moving from here to here. Suppose vectors are moving from A to B. It is A to B. Okay, it is moving in this direction. So how you can show the resultant? So your fingers are moving in this direction. Okay. So okay. So your thumb will be. So this is what your thumb. Okay. So your fingers rotated over here. So A to B, your fingers are showing direction of the cross product A to B, and this is showing what? This is showing you resultant. Okay. Now if you reverse that one, if you want to move from B to A, if you want to move from B to A, so now what will happen if you want to move from B to A? So now you have to find what in the reverse order. So what will happen? Your fingers will come from here. Okay. So this is what going to be now. And this is what going to be your finger. Okay. So you know whatever that one you can draw it better than. Okay. So this is what going to be your finger. Okay. So don't worry about the hands. So what will happen now if you just show like this, it is coming from B to A. So now these are coming in this direction. This is show you what? That will show you the direction of you are moving the screw. Now this will show you what? In which direction the screw is moving. So that means this will give you the resultant. Okay. So what you can tell from this one is the fingers of right hand will give you the what? Direction of whether it is A to B or B to A, or direction of vector moments. Then thumb will give you what? Thumb will give you the what? It will give you the resultant. Okay. So fingers. So fingers will give you what? Moment of vectors. Okay. Moment of vectors. Then thumb. Thumb will give you what? It will give you the moment or direction of resultant. Moment or direction of resultant. Okay. So here also moment or direction of vectors. Okay. So I hope you can understand. Suppose vectors are here. Suppose these two are the vectors. Okay. Suppose these two are the vectors and vector going from A to B. So what will be the result? A to B. So they are moving from A to B means this is A and this is B. So vector is towards me. If it is moving from B to A, so from red to black, if it is coming from red to black, so what you can say? So red to black. So direction is towards you. If black to red, so from black to red, direction is towards me. Thumb is here. Okay. From red to black, direction is towards you. Okay. If I hold it like this, okay. Red to black, black to red, so direction is what? Upward. Red to black, so red to black, so direction is what? Direction is downward. Okay. So if I hold like this, black to red, so direction is towards this one. Red to black, so direction is towards this one. Okay. So however I can hold like this. So black to red, so how you can hold? So you can hold like this. Okay. So black to red, so it is in this direction. Okay. So red to black, it is in this direction. So remember, so you have to hold your finger. So finger direction will give the moment of vectors. So thumb will give you what? Thumb will give you the direction of your result. So that is very, very important. Remember that rule, right hand screw rule. If you hold your thumb, right hand, so then what will happen? The other fingers will show you what direction of moment of vectors. Then thumb will show you or give the direction of resultant. Okay. So let me take a small example with the direction we can tell. Suppose you are having a plane in this direction. Okay, so you are having plane on the board. Okay, so board is only going to be a plane. Okay, so this is vector A, so having magnitude 2. So this is vector A and another is vector B is here. Okay. So think that it is moving from A to B. So what you want? You want to find A cross B. What they are given? They are given magnitude of A equals to 2, magnitude of B equals to say some 4, and theta you can take it as say theta you can take some angle 30 degree only. So how you can find A cross B? Magnitude of A, magnitude of B, sine of theta, n cap. Okay. So what is magnitude of A? 2 and magnitude of B is 4. Sine of 30 degree. So n cap write as it is. So later we will see that. So 8 sine 30 is what? Sine 30 is 1 by 2 and n cap you write as it is. So 2 4. So 4 n cap is going to be what? Your A cross B. Now n cap you have to define, that is very very important. So see here, take this as x over x and this as so y. So remember they should mention also it is a xy plane or yz plane or whatever. Now what I will say, I will tell this as a yz plane. Okay, yz plane. So this is y and this is z. So if it is yz plane, what is resultant? So resultant is going from y to z. So it is going from here to here. Resultant is along what? Resultant is along x. So x may come over here also. Okay. So what I can write? I can write along x here. What you can write? I cap. It doesn't mean that you have to always take what I here, x here only, y here only. They have given this as yz. So here it is going to be what? It is going to be x. So this is what? I cap. So n cap, in place of n cap, what you can write? You can write it as I cap. Okay. So A cross B 4 I cap. Okay. Actually they won't give like that, but to understand that direction, I can just taking in this example. Okay. So if they reverse it, if they make it to say B cross A, then what will happen? This will become 4 n cap will not change as it is, but n cap direction B to A. So from here to here. So from here to here, it is coming from here to here. That means your resultant is into the board, means negative of I. So minus I cap. Okay, so this will become minus 4 I cap, like that. So you will understand the directions properly when we study the cross product of unit vectors. So there we will get what I